Hi everybody. I think you can hear from the voice here that I haven't really gotten too well yet. So unfortunately our lesson today will also be a digital one. I can't wait to come back and have proper lesson with you guys. But let's review what you guys did today. It's 11:55 right now. I just woke up from a nap after taking the medicine. So let's review what has happened today so that tomorrow during lesson time, you know what are the common mistakes made, what are the things to look out for, and what our lesson will be like moving on. Okay, so in lesson 2, we started off with this. I asked you what type of hazard is an earthquake. Most of you correctly identified this. Almost all of you as tectonic hazard. Very good. Climate related hazard are the kind that you can see in the atmosphere. So tectonic hazards like the one like earthquakes or even the most recent one. I don't know whether you guys have been watching the news. I think in Tonga or something like that. The underwater volcano that erupted. So these kind of things we don't really see what's the cause. So these are tectonic hazards. Okay, I also asked what type of hazards occur anywhere in the world. Most of you got this right, but there's still a handful who got it wrong. So climate-related hazards are the kind that happens anywhere because anywhere that there is air, anywhere that there is sunlight, we're prone to climate type hazards like Singapore, flooding, droughts. But we don't have tectonic hazards because we are far away from a tectonic plate boundary. Excuse me. Alright, I asked the question as well here. Which part of our planet is liquid in state? Okay, most of you correctly identify outer core as the one that is liquid in state. Just a reminder, our planet is very, very, very similar to that of the Ferrero Rocher, with only one exception, if I recall highlighting this in class, is that our inner core, the nut that we have, there is a layer of protective liquid around it. So that is the outer core. Okay, and that's the only one that is liquid. Continental crust, I agree, there may be some with water on it, but it is not made of water, because the question is asking which part is liquid in state. Okay. Next question is asking you about which part of the planet follows the convection current. Now this one, most of you got this correct. The answer is asthenosphere. Okay, convection current, as you will have learned in your lower sec science or even primary school science, where heat causes things to move around. So the only thing that is influenced by the heat of the core. If you recall, so we mentioned in lesson that the core temperature is between 3 to 5,000 degrees Celsius. The only thing that is influenced by that is the mantle layer, of which asthenosphere is part of the mantle layer, okay, the uppermost layer. So if you're wondering, as I'm going through this, what do? Record. Record this into your digital notes. Record this into your physical notes. Sorry, not the digital. You know the hard copy physical notes that was given to you? Yeah, so that is where you record all this information. Okay. So I give you a recap with this slide that gives you all the details about the various layers. But as I mentioned to you in class, to please go home, read your textbook as well, you realize actually certain things like the fact that the mantle layer makes up 80% of our Earth volume that's not written in here. There's only something that you can read. Similarly, we're talking about the difference between oceanic and continental crust. Not just a simple matter of where you can find it, but also the age, the density, and the thickness. Now, two of these are going to be very important in the coming lesson. Alright, so I gave you this lesson, this video about convection current. For those of you who are rusty, it's been a while since you last talked about convection current in physics lesson or what have you. So this was meant to be a quick excerpt to highlight to you how convection current happens. But the step-by-step, blow-by-blow is the fact that the core at 3 to 5,000 degrees Celsius is the source of the heat. If you remember back when you were a student, they would show you, you're still a student, sorry, when you're talking about lower sec science or primary school science, there's a Bunsen burner, the fire, right, that causes the water to move according to convection current. Okay, so there is a source of heat. In this case, the heat is sourced by the core at 3,000 to 5,000 degrees Celsius. What happens to the mantle material is, because of the heat, it expands. I mean, the more technical one is, it expands. So the molecules are further apart. It becomes less dense. So then it can start to rise. It's like ice in water, you know. When it's less dense, it will then float. I mean, long answer short, you can just say mantle material heats up, expands, and rises. And once it reaches the edge of the planet, there's nowhere else for it to go. It will spread out. And as it spreads out, surface area is large, it will lose that heat and it will cool down, causing it to become denser and eventually sinks back to the core where the whole process repeats again. So this happens under our Earth's surface. So the question is, how will you explain this? This is the step-by-step in a written form. But as we did as our practice with the Kami assignment, you also were practicing how to annotate in a diagram. Okay, so this is how the tectonic plates move. So the idea behind this is the convection current on the mantle layer, of the mantle layer, is causing the crust itself, where we are standing on, to also shift. So what do I mean by this? Imagine if you are a surfer, you're standing on the surfboard. Even if you're not putting in any effort, no paddling, no nothing, you're just standing on top of it. If the water itself is moving, the surfboard will also move along with it. So what happens is the earth will therefore keep moving, the earth's surface will keep moving along with the convection current that's happening underneath our planet. So what are the various ways that it can move? I highlighted two particular ways. Spreading, where the plates are moving away from each other because the mantle material is spreading out. Or opposite here being slap pull, where as the material meet each other and they start to sink, okay, the plates are pulled towards each other, and then one plate will subduct underneath the other. Now here, if you can see, I bring up the idea of the denser plate. Recall, between the oceanic and continental, oceanic is the denser plate, so always the oceanic plate will subduct. And then when it subducts, it will drag the rest of the plate down together with it. If you're not sure what subduct means, subduct basically just means it goes underneath the other one. Okay, so as it moves, it goes down underneath instead of pushing against each other. Okay, so you can see from this diagram, the next slide here, that, see, imagine if there's a conversion current going on. This area, there is more mantle material moving this way. So you can see that here is moving here. As that happens, the denser crust will go underneath, and as it goes underneath, it will pull the rest of the plate down together with it. So that is the slap pull phenomena. Okay. Now I gave you this video about Scrat and how the, or at least in this Ice Age video, they show how the crust is being deformed and how the continents are being formed. So most of you can correctly identify that actually there's a lot of anachronism, a lot of errors in this video, including things like mantle material is the thing that moves. It's not the earth core that spins. The earth core is not that small. That there is an outer layer of liquid, so Scrat shouldn't be able to run around. It should rather be swimming. Temperature has to be so high that Scrat would melt the moment he enters. Honestly, I don't know what's going on. I don't know why it's not showing all the responses. But it's okay, we move on. I've also asked you, now that you know about the plates moving, what is therefore the cause of, let me just try this out one more time. Hopefully it will be able to show your responses, because there's some really good responses that I wanted to use. 3 Topaz lesson. Alright, okay, sorry for the airtime for a while there. Here, okay, so you can see there are responses, good ones coming in from the class. Then one that is quite commonly said, not just by our class, other classes as well. The nut will not cause the ground to split. Yep, very true. So there's a lot of good responses being given. There's no liquid in the mantle in the video. The inner core is not hot at all. Yeah, so there are a lot of errors that you correctly point out. So we already now know convection current causes the plates to move. Ask you to identify where Singapore is found. So Singapore is found there. So yes, Singapore used to be at the North Pole. We used to be so freaking cold. But now we are near the equator. So I asked you, using a map of earthquakes shown in the next slide, where do you think the cracks are now? Okay, most of you can correctly identify the cracks are exactly where the earthquakes are. So thank you for that. Good, very good detailed responses by quite a lot of you. Thank you for Visme for giving this kind of response. But nevertheless, I also wanted to ask you if you could draw, what's the direction the plates are moving, because I wanted you to try and guess. if you can see here, there are actually different parts, different areas where there is a lot more earthquake happening here compared to around this area where there's very little earthquake. Yeah. So I wanted you to be able to identify that where there are more earthquakes, that means the plates are moving towards each other, which gives you a hint actually. So what earthquake is basically a phenomenon that occurs when the plates are rubbing against each other. You build up the stress and then suddenly you release, it forms an earthquake. Not to worry, we'll go through in detail about what earthquake is like. But the idea behind this is the more the earthquake, the more the plates are actually interacting with each other. So I gave you this map ultimately to tell you about what type of plates there are and what are the plate direction movements there are. So I've had questions being asked before. Does that mean that I need to memorize every single one of this? So I have good and bad news. The good news is you don't have to memorize all, but the bad news is you still do have to memorize some. So I'm going to give you a tip though. There are only 3 where you need to try and memorize the names. The rest of them I find are fairly straightforward. For example, North American plate is where North America is. South American plate, where South America is. Africa and Eurasia is where all the continents can be found. Straightforward, right? Even Australian can be found where Australia is. So this is an old map. There is now a new line here where the Indian plate is separated from the Australian plate, which means what are the remaining plates that you need to be familiar with that Cambridge is expecting you to know. They will expect you to know where's the Nazca plate, where's the Philippines plate, and finally where is the Indian plate. Okay, the rest of them I think should be fairly straightforward. Sorry, I forgot one more. Pacific plate, named after the Pacific Ocean. Every other type of plate you can see is easy for you to remember, except for maybe these 3. Philippines, Nazca, and Indian plate. Okay, then we move on. So what's this divergent plate boundary? As you can see, it literally just means they diverge, they move away from each other. I asked you, what can you see in this diagram here? So most of you can correctly tell me the fact that the molten material is moving up through the oceanic crust. Some of you are telling me that there is a crack, that there is a gap, there's an opening there. So the molten material from the mantle rises up to form this new seafloor. Okay, so let's take a look at how to explain this in detail. Now, this video, I'm not disabling this pair deck lesson from today, which is the day before. That information will still be available. You can click the link to go into the YouTube video. You can follow Bowen Job as a geography YouTube channel. That's actually my channel. It shows a whole lot of information as to like how this plate boundaries and all thing happens. So the idea behind this, it shows step by step what happens to result in the final formation of the mid-oceanic ridge in this case. Okay, so what I'm expecting to see in your submission is actually this. You know the Kami assignment? See what happens at oceanic divergence, continental divergence. I'm actually expecting to see this as a step by step. What happens? Okay, now I can see from a lot of you, your responses, most of you can correctly, well, basically you know what I'm expecting to see, which is from this YouTube video, but some of you, I can tell you're copying from your textbook diagram, which diagram quality wise, the actual drawing, I think we went through in class, is maybe equivalent of a mark, not that big a deal. The important ones is to talk about the process. So in this case, your process must always start with step 1, the convection current in the mantle. This is the common mistake. Second common mistake is people who are writing down there, magma rises and then it forms the mid-oceanic ridge. So for those of you who did, I wrote down there as a comment, avoid using generic terms like forms or creates. Maybe be more specific. The magma rises to fill up the gap. As it reaches contact with cold oceanic floor, it solidifies into the mid-oceanic ridge. So that is what they're looking out for. Yeah. So that means you're able to show the process a bit more clearly. Alright, so that's what's happening at an oceanic divergence. Again, oceanic, if you recall from the characteristic, it is thin. So when you split them, it's easy for it to rip in half and tear. But when it comes to continental crust, however, it's not going to be as easy. Because while you can tear a piece of paper, on a continental crust, given that it is much thicker, you cannot just tear a textbook just like that. maybe if you're strong enough, you might be able to tear some of the pages on the inside as you pull it apart. So what happens there is it will form fractures inside the textbook, in this case continental crust. The fractures then eventually line up for a portion in the center to sink. That is what forms the Rift Valley. Okay, so I asked you to draw the diagram for it as well, and again the video has been uploaded. Now these two videos are a series of I think 5 to 6 videos about plate boundaries. I know your seniors in their prep for O-levels, they are rushing through to rewatch this over and over again. It's not a must right now. You can definitely just go all the way to the last scene for you to see what the end product would be. But it's better for you to understand the process, how it happens through watching the whole video again. So what I would like you to do is, the Kami assignment, I've written back, with the exception of 5 people who did not submit their work. Let me name them. Unfortunately, these 5, I did not get your work. For the rest of you, I have marked, I've given you feedback, I have returned it back to you so you can see. What I would like you to do is I want you to do your corrections. So your corrections, what I want you to do is to draw the final diagram for both OO divergent and CC divergent. Okay, so if you're wondering how to go about doing that, there's a lot of stuff, right? So you can see here there is a plus sign at the bottom. For example, this is Yuchen's one, right? You can press the plus button at the bottom and it will bring you to a brand new page. And a brand new page, then you can redraw back the diagram. It can be your corrections. Yeah? Okay, that's all I have for you guys for today. The remainder of this lesson, because this is a relatively short video, remainder of this lesson, you're going to go through another one of the plate boundaries. This time around, we're going to talk about oceanic continental convergence to see how the difference in density, difference in thickness results in the formation of a certain type of feature. Okay, see you guys. Sorry I can't see you live this week. Next week I'll see you guys.